Okay, so what are we going to do for this one? They're asking us to use any of these three methods. You can use prime factorization, the old Chinese method, or the Euclidean algorithm, any of them, to find the greatest common factor of 910 and 952. It doesn't really matter what method you use. Honestly, I don't even know what the old Chinese method is. You could read, it's in our textbook, I'm sure. I just grabbed a free textbook online that came recommended. I haven't read it all, to be honest with you, and I've never studied the old Chinese method. You could go on Google or go to our textbook and you could read about it if you want to do that. I might actually later if I have a moment this afternoon, but right now we've learned the prime factorization method, and we've learned Euclidean algorithm, which is the long division where you rotate. I prefer the prime factorization. I found that's easier for students over the years, so I'm going to do it that way. But if you really want to do the long divide, rotate Euclidean algorithm method, feel free. Doesn't matter, just any which way. Let's find the greatest common factor, or the greatest common divisor, same thing, of 910 and 952. In other words, what's the biggest number that divides evenly into 910 and into 952? Well, I'm going to do it by prime factorization. So I'm going to make a little factor tree over here, and I'm going to find the prime building blocks of a 910. What goes into 910? Well, I could divide by 2 here. 2 times whatever, but it would be easier to do 10. It's 10 times 91, because anytime a number ends with a 0, you know it's times 10, right? So that's a little easier. And 10 is 2 times 5. 91, use your calculator. If you divide by 7, you'll find it's 7 times 13. So the prime building blocks of the 910 are 2, 5, 7, and 13. I'm going to cross out the 10 and the 91. Why? Why am I crossing out the 10 and the 91? Well, because those numbers broke apart, didn't they? 10 broke apart here and became 2 and 5, and 91 broke apart and became 7 and 13. So they're not prime. 91's not a prime. It's not a fundamental block. It's made out of 7 times 13, and 10 is made out of 2 times 5. I just want the prime building blocks. So I'm not going to list the 91 or the 10, right? Because that's not a prime piece. So I just go all the way down until I get those numbers that won't break down anymore. These are the pieces that make a 910. If you take your calculator and you multiply 2 times 5 times 7 times 13, you'll get 910. Those are the building blocks of a 910, the prime building blocks of a 910. Okay, 952, let's do the other number. And again, I'm going to use my calculator. Divide by 2. 952 divided by 2 is 476. 2 is prime. Let's divide by 2 again. I don't know what's in 476, but I know it's divisible by 2 because it ends even. And then I can do 2 again because I know 238 ends even. Now 119, that's a weird number. Try dividing by different things. Try dividing by 3, doesn't go. 5 doesn't go. 7 actually goes. 7 and 17. Now, again, I'm going to cross out the numbers that broke down, right? The 476, the 238, the 119, they broke down into smaller numbers, didn't they? And so we don't need those. All right, so what does this all say now? Let's go over here on the side. And what we're going to do is we're going to line up the primes. So 910 is 2. I'll leave room for the, well, I'll just put the 5 next, I guess. 2 times 5 times 7 times 13. That's the 910. And the 952, I'm going to line up the primes. He's got 3 2's, doesn't he? So 2 to the 3rd power times 7 times 17. See how I gave every prime its own column? You remember this. This is how we do this, okay? And now, let's do it. So the GCF or the GCD, same thing, whatever. So how do we find it? What is going to be the GCF or GCD of these numbers? Well, remember, it's what they have in common, right? It's the greatest common factor. So it's what they have in common. So when it comes to the twos, how many twos do they have in common? How many do they both share?
One.
Yeah, just one, huh? Right? They both have 1 2. They don't both have 3 twos or 2 twos, but they both have 1 2. When it comes to the fives, how many do they have in common? How many do they share? How many do they both have?
0.
Yeah, none, huh? None here. And when it comes to sevens, they have 1 7. They don't have any 13s or 17s in common. Exactly. So the greatest common factor is all about what they have in common. So what does it equal then? The GCF then is 2 times 7. You multiply those together, which is 14. And there it is. We're done. The GCF is 14. Do you see what we did there? We found out the greatest number. What that is, you can check it if you're interested. You take your calculator, take 9, 10 divided by 14. It'll go in perfectly evenly. Let me see, I'll do it in my calculator. 65 evenly. And if I take the other number, the 952, and divide it by 14, it's a 68. 14 goes into both of them evenly. How do I know? Well, because 910 has a 2 and a 7, 14, and 952 has plenty of 2s and a 7. So do you see 14 is really inside of the 910 and inside of the 952. In fact, it's the most they share in common. They both share a 2 in common. They both share a 7 in common. That's the greatest amount they share in common. So therefore 14, 2 times 7, is the greatest factor that'll go into both of them. That's the greatest number, the biggest number that'll divide evenly into both of them. It's the most they share in common, the greatest common factor, 14. Questions on that? So I did it by prime factorization. You could have done it with the long divide Euclidean method. That would get the same answer. It doesn't matter which method you use, or you could look up the old Chinese method. I'm sure that would work too.